Good morning, students. How are you? I hope you are all well. In the last video, we'll discuss about gradient of scalar field and its physical significance. Today, we'll discuss divergence of a vector field and what is its physical significance. As you know, when del operates the vector field, means there are two products, one is dot product, another is cross product. If the del operates vector field, means dot product, which gives the divergence of the vector field, and if it is a cross product, that gives the curl of the vector field. Now mathematically, divergence of the vector field means, as I said, it is the dot product. As you know, the del is an operator. You can represent it as I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. If the vector field E in Cartesian coordinates with respect to x and y z directions, you may write vector E is equal to Ex I cap plus Ey j cap plus Ez k cap. That should be z, not y. If you multiply or you take del dot E, just product of del operator and the vector field, and you know I into I becomes 1, means here unit vector multiplication gives the 1, I dot I gives the 1. So naturally you will get dou Ex upon dou x plus dou Ey upon dou y plus dou Ez upon dz. And the mathematically the divergence means multiplication of del operator with the vector field. You will get only magnitude. The result is only magnitude here. Yes or no? The I cap, j cap, k cap get cancelled. Means there is no question of directions. Means divergence of the vector field gives the scalar. Means gives only magnitude but not directions. Here you should remember the direction disappears. Means only it tells about the magnitude of the vector field. So mathematically, actually what is the meaning of divergence? As you know, diverge means moving away from, divergence mind, isn't it? Divert mind. So similarly, divergence of the vector field, the divergence of the vector field given a scalar field means it measures how much the field emerges or diverges from the point. Means here the amount of field emerges or diverges from the point. Means here there are three types of divergence. Means you call positive divergence, negative divergence and zero divergence. As I said, divergence means how much the field, how much flux moving away from the given point, how much it moving away from the point. For example, positive divergence. Here you consider the point where the field is moving away from the point. It moves away from the point, that is called positive divergence. Means the point P is positive divergence when the field or flux is moving away from the point. See, the arrow mark represents away from the point. That is called positive divergence. Negative divergence. Negative means the field is moving towards the point. That point you consider as a sink. The previous case, the point called as a source, means from the source the field is moving away from the point. That point is called source. And here the field is sinks, means it is moving towards the point, that is called a negative divergence, or you may call sink. And another case is zero divergence. Zero divergence means the point neither source nor sink. In the sense, the field enters in the point P and the field moves away. The magnitude is same. The magnitude is and direction is same. Here the point is called zero divergence. I will give one analogy. See, you take one pipe. Yes, this is the pipe. The water enters here and the water comes out. Means this is in, this is out. Suppose the water is flowing inside this end and here you adjust, means connect another pipe, you just water is added here. So what happens? The quantity of output of water is greater than the input, means addition is there, isn't it? So the output, the quantity of water flow, the rate of flow, the mass of rate of flow is greater here, then it is called positive divergence. Positive divergence. And a negative divergence, same similar pipe, here the water enters, here the water leaves out, means coming out, and here some leakage is there. Leakage is there, means the whatever the water enters and the amount of water leaves from the other end is less, means entering is more and leaving is less, and you call it is what you call a negative divergence. And in third case, so there is no leakage, no addition, the whatever the quantity of water enters at one end and leaves at other end, and here the water is the same, means input is equal to output, then you say zero divergence. Means here it divergence, it gives tells us about a change in mass rate of flow of water. Mass rate of flow of water, that is what you call physical significance. Physical significance means it tells the divergence of a vector field simply measures the how much the flow is expanding at a given point, and it does not give indicates in which the direction the expansion is occurring. In the sense, mass of rate of flow, how much flux flowing outwards, yes, but it will not give the direction. That is the physical significance of divergence. In definition, see here. The divergence of a vector A at a given point P is the outward flux per unit volume as the volume shrinks about the point P. Means the divergence of the vector field at a given point is the outward flux, means outward flux per unit volume as the volume shrinks about the point P. I will give one example. You take a balloon here. This is the balloon, isn't it? It is filled with the air, and here just open it. What happens? The air flows out. The air flows out. Means at this point, the flux, outward flux, how much air is flowing? Yes, from this point. That is the flux flowing per unit volume, isn't it? And this is sinks. The volume is sinks. That is the meaning of divergence. I repeat, divergence of the vector at a given point P is the outward flux per unit volume as the volume shrinks about that point. Mathematically, you write divergence A is equal to del dot A equal to, you take limit del V, means that is the unit volume, surface integral is A dot ds divided by volume, that is dv is equal to unit volume, and surface integral A dot ds gives the net outward flux. Means the divergence of the vector field gives the scalar quantity, means it gives how much flux outward per unit volume, how much flux is flowing per unit volume. It does not give the any directions. That is the physical significance of the divergence of the vector field. I hope you understood this concept. Next period we will discuss curl of the vector field. Thank you.